In this video, we are going to look at a concept that all of us have experienced in daily life, elasticity. Right? Let us begin with a very, very common example, right? A rubber band, right? Or elastic band. This is its original shape and size, right? It has a certain length. Right? When we apply a force on this, right? When we apply a force, like I'm applying a force on this, and what we see is that it is getting elongated, its shape and size is changing. Right? But the most important property is that when I release the deforming force, it goes back to its original shape and size. This particular property is known as elasticity, the property to regain the original dimensions or shape and size on removal of the deforming force. Now, this property of a substance is known as, or any material is known as elasticity. Another point that I want to draw your attention to is this. Again, this is the original shape and size. When I apply a force on this, it is getting deformed. When I release the deforming force, it goes back to its original shape. Right? It has a tendency to go back to its original shape and size. What this means is that when I am applying the deforming force, there is another force which is getting set up inside this rubber band, right? Which we will call as the restoring force, because it has the tendency to bring it back to its original shape and size. So when I am applying a force, deforming force, a restoring force is getting inside, and when I release the deforming force, the restoring force makes it come back to its original dimensions, right? So the force that I'm applying is the deforming force. The force that gets set up inside the rubber band is known as the restoring force. Right? And primarily we will talk about the restoring force and not talk so much about the deforming force, even though the fact is that one generates another. Rather, the deforming force generates the restoring force. Right? And maybe we will denote it by Fr. Right? Okay. This is about elastic substance. Now, a substance which does not show the property of elasticity at all is known as a plastic substance, and the property would be plastic. For example would be, say for example, wet clay. When I apply a deforming force on wet clay, the clay does not regain its original shape and size. It retains the new dimensions, the new shape and size. So it does not display any property of elasticity. It is known as a plastic substance. Right. So we have just got an introduction to elasticity, and now I will talk about something known as limit of elasticity. Right. Let us say we have a thin rod of some particular metal, right? These are the various cross sections of this rod, and let us say I am applying a deforming force, right? Fd. Right? This Fd will generate Fr inside, right? Restoring force. So let us say I am applying deforming force. When I apply this deforming force, this rod will elongate, and when I remove this, it will go back to its original shape. The question is, what would happen if I continue to increase the deforming force, say, indefinitely? So as I keep on increasing the deforming force, what happens? And when it reaches a particular value, what happens? It is observed that up to a certain value, this particular rod continues to display the property of elasticity. Okay? Say for example, let us say we begin by a deforming force of say 11 Newton. As I keep on increasing this value, this particular rod continues to show the property of elasticity, meaning that it elongates and then goes back to its original shape and size. But at one particular value, right? After I have increased it, right? At one particular value, say for example 106 Newton. This is just an example I am taking. What we observe is the rod loses its property of elasticity, meaning that it retains its new shape. So for example, at 106 Newton, if it has elongated this much, of course we are exaggerating this. Right? If it is elongated this much, it does not go back. It retains this particular length. This particular value of the deforming force, wherein the substance or the material or the object loses its property of elasticity, is known as limit of elasticity. So limit of elasticity is value of a force, deforming force, which if applied on an object, the object loses its property of elasticity. And different materials would have different values of limits of elasticity. Correct. So we have looked at limit of elasticity. Let me go back to the two terms that we have talked about. There are two things that we have looked at. One is the deforming force or the restoring force, or simply force which is being applied on this object. And this force is leading to deformation or elongation of the object. So this is the kind of the cause and this is the effect. So I apply a force on an object, the object gets deformed. In physics, when we want to understand the relationship between any two physical quantities, in this case force and deformation, I need to quantify them. I need to find out physical parameters which will help me understand the relationship between the two properties, in this case force and deformation. In this case, to understand the relationship between these two, we have introduced two terms, right? First term is known as stress, and stress is given by the deforming force or the restoring force, right? We will now start using the term restoring force, right? Restoring force per unit area, where area is the cross-section area. This particular force is being applied onto this object and it is experienced on this cross-section area. The restoring force is getting developed in this direction. This is the direction of the deforming force. The restoring force is getting generated inside this particular object and it is acting on this cross-section area. So this restoring force per unit area developed in this particular rod is stress. That is the stress under which this rod comes when we apply the deforming force. So that is stress. Stress is force upon area, and the units will of course be Newton per meter square or Pascal. Force is Newton, area is meter square. Once again, this area is not the surface area of the rod, it is the cross-section area of the over here. Right? Okay, so this term will give me an idea about what force I have applied, or what is the stress under which this particular rod is. And as far as effect is concerned, or the deformation is concerned, we have a term strain. And strain is given in this case by change in length per unit length. We have applied a force, deforming force, that is the cause. The effect is that this rod elongates. Now what is the elongation per unit length? So if it elongates by 2 millimeter, right, I'll write 2 millimeter over here, and if the length of the rod, original length of the rod is 100 millimeter, 2 upon 100. Right? So this will give me an idea about the effect of this particular force. This, since it's a ratio of length, has got no unit. Okay, so we have introduced two terms, stress and strain, and they are nothing but basically representation of the force and representation of the deformation. They are nothing but the cause and the effect, right? Stress and strain. And now we will look at what is the relationship between stress and strain, right? Having introduced these two terms, what is the relationship? It is observed that stress and strain are directly proportional for small values of strain. Right? So if the value of strain is not too high, that means if the deformation is not too high, stress is directly proportional to strain. And that is very logical and understandable. If I increase the cause, effect is going to get increased. If I increase the stress, strain is going to increase. So this is the directly proportional relationship between stress and strain. And therefore, I can write down stress upon strain will be some constant E. Right? And this E is known as modulus of elasticity. And the value of this would be constant for a given substance. So if I know a particular substance, if I'm using a particular substance, I would know the value of modulus of elasticity, and then when I apply a particular stress, a particular force, I would be able to find out what would be the strain. So this particular equation helps me to understand the relationship between stress and strain for a given substance, and this is known as what you would have studied in lower classes as Hooke's law. Right? Hooke's law gives us the relationship between stress and strain. Once again, to stress, this is applicable for very small values of strain. Okay, so in this video I have introduced what is elasticity, what is limit of elasticity, what is stress and strain, and what is the relationship between these two terms. In the next video, we're going to look at these particular concepts of stress and strain in more depth. We'll look at how different forces are applied, that how the nature of forces changes the value of strain or changes the value of strain, right? And how we can have different types of forces acting on objects and creating different type of stresses and strain, right? Thank you.